Good morning. This lesson is for my Integrated 1 classes and my Honors Integrated 1 classes. But before I get started, I want to say I hope that everyone's doing all right up there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of are 2 goals for the day. Our first goal is going to be to learn how to graph linear inequalities in slope-intercept form. And our second goal is going to be to understand what the shading implies and the difference between solid and dashed lines. I'm going to do both of these goals at the same time. So before I start this lesson, I want to remind you guys about the previous lesson, and I believe it was about buying shirts and hats. And what we did in that previous lesson was we were given a budget to spend money on shirts and or hats. And so what we figured out was how many shirts we could buy if we only bought shirts and how many hats we could buy if we only bought hats. That gave us 2 ordered pairs, which is what we need to write an equation of a line. Well, once we wrote this equation of a line, we discovered that any point on this line represented spending the amount of our budget. We also saw that if we were at a point below the line, we were spending less than the budget, and if we were at a point above the line, we were spending more than the budget. And so that lesson was shall I call it a prequel to this lesson. So if we're above the line, it's more than it, and if we're below the line, we're less than it, okay? So let's go ahead and jump into the lesson. Now, I have on the board a table. I would like you to add that to your cheat sheet so you have the rules in front of you. Shading rules for inequalities in slope-intercept form. I'm going to shade below if I have this symbol or this symbol. I'm going to shade above if I have this symbol or this symbol. My line is going to be dashed if I have this symbol or that symbol. My line will be solid if I have this symbol or that symbol. So we need to know what we have in order to graph. Now, the nice part about graphing the nice part about this lesson is we know how to graph in slope-intercept form. We find the b value on the y-axis and we use the slope to move to the next point. Once we have those 2 points, then we follow the table and we just basically finish. Now I do want to again, like I said, kind of combine these goals with each problem so we can see this worked out. All right, so problem number 1 or example number 1, I'd like you to graph y is less than or below 2x minus 3. So remember, in order to graph, I need to know 2 things. I need to know my b value, and on this problem, my b value is -3, and I need to know how I'm moving. So my m is just a 2, but I can add a 1. I know that I'm rising up, and I know that I'm running to the right according to my slope rules. So again, I'm going to start the problem like I already know how to do. I'm going to begin at -3. I'm going to go up 2, right 1, put a dot. Now I'm going to look at my table. I have this symbol, so my line is dashed. So I'm going to draw a dashed line. Okay, so make sure you draw a dashed line. And again, because I have this symbol, I'm going to shade below. So when I shade below, I'm just going to draw some lines off my graph like this. Okay, so now we're going to talk about the second goal here. Understand what the shading implies and the difference between solid and dashed lines. Well, first let's talk about the shading. Okay, the shading. The shading represents the solution. So what that means is if I pick any point in the shading, I should get a true statement. Now, I like working with zeros. So what I'm going to do is I'm going to pick this point right here. And that point is, let's see, 1, 2, 3, 4, x is 4, y is 0. If I was to plug in 4, 0 into this inequality, I'm going to get a true statement. So let's see here. My y value is 0. And my x value is 4. Let's see here. So it becomes 2 times 4 minus a 3. I get an 8. 8 minus 3 is a 5. And 0 is smaller than 5. That is true. So again, if I have a solution, I'm going to get a true statement. So any point in the shading represents a solution. Now let me talk about a dashed line. a dashed line here. Let me try and find another color here. Dashed line. Let's hope this green marker works. A dashed line. Oh, I just used green. Why am I using green again? It's early. I guess I can use a black marker again. All right. So a dashed line is a boundary where there's it's a boundary where there are no solutions. Okay. Now this seems kind of odd, but think about it like a line on a football field. If you touch the line, you're out of bounds. You're no longer in the playing field. So this is not part of the solutions. It's out of bounds to the solution. So it's a boundary line where there's not a solution. So for example, if I was to plug in the point 0 for x and -3, if I was to plug in 0, -3, let's see here. So 0 for x, so now I'm going to go y not equals less than 2 times 0, it's not y, it's -3, sorry, minus 3. 2 times 0 is 0, 0 minus 3 is -3. Is -3 smaller than -3? No, that's false. It's not true. So -3 is not smaller than -3. And that point came from the boundary line. And so again, it's a boundary line where it's not a solution. So the shading is a solution, the boundary line is out of bounds. It's not part of the solution set. All right, let's move on to example number 2. And again, we know how to graph this. This is graphing like the previous chapter here. So our b value on this problem is 2. Our m, I'm going to put the negative up top, is -1 over 3. So I'm going to rise in the negative direction and run in the positive direction. So again, I begin at 2. I rise down 1 and I run 3. Now let's use our chart. I have that symbol, which means that I have a solid line. And I am going to shade above. So again, we saw that if we shade is the solution, but I want to talk about the boundary line here. This point is 3, 1. Now, you can be strategic where you pick your x values, and let me go back here. I'm going to use this point to show you what the difference is between a solid line and a dashed line. A solid line is a boundary line where we have a solution, so the line is inbounds. So it's like soccer. If you're on the line, you're still in the playing field. So this boundary line represents solution. So a solid line is a boundary line where we have solutions. So for example, I can look at the point 0, 2. 0, 2 is on the boundary line. If I plug that in, I should get a true statement. My x is 0, my y is 2. So 2 is greater than or equal to -1 over 3 times 0 plus 2. -1 over 3 times 0 becomes 0. 0 plus 2. 0 plus 2 is 2. 2 is greater than or equal to 2. This is true. So again, I'm showing you that we have a solution because I got a true statement. So again, we're not adding much. We're really just adding this to a process that we know how to do. All right, so I'm going to go ahead and end this lesson here. Hopefully you understand the process, and again, add this to your cheat sheet. Dashed lines are boundary lines where we don't have a solution. Solid lines are boundary lines where we have a solution. And remember that the shading represents the solution. So I'm going to go ahead and end this video here. Again, I hope everyone is doing all right up there. Have a great day, everybody. Bye-bye.